What if a huge space rock slammed into Earth tomorrow? How big does an asteroid need to be to cause serious damage? What are the odds of Earth getting hit by an asteroid? How do scientists keep track of asteroids and stop them from hitting us? Wondering about these questions? Stick around, because what GlobeMind will provide you with all the answers. The impact. When a large asteroid, like the one that led to the extinction of the dinosaurs approximately 66 million years ago, hits Earth, the immediate effects are devastating. The impact releases an incredible amount of energy, equivalent to billions of tons of TNT, creating massive explosions and shockwaves that travel through the ground and the air. The asteroid that struck Earth and caused the extinction of the dinosaurs was about 6 miles wide. Upon impact, it created a crater over 90 miles wide and 18 miles deep, known today as the Chicxulub crater in Mexico. The force of the impact was so immense that it sent shockwaves and debris flying across the globe. The heat generated by the impact was intense, igniting wildfires over vast areas. The dust and debris thrown into the atmosphere blocked out sunlight, leading to a global cooling effect. This caused a drastic drop in temperature, resulting in a nuclear winter scenario that lasted for years. The combination of these effects led to the extinction of about 75% of all species on Earth, including the dinosaurs. To put the scale of this impact into perspective, the energy released by the asteroid impact was estimated to be equivalent to more than 1 billion times the energy of the atomic bombs dropped on Hiroshima and Nagasaki during World War II. The devastation caused by such an event is unimaginable, highlighting the importance of understanding and monitoring the threat of asteroid impacts on Earth. Devastation. The potential devastation caused by asteroid impacts is immense, with the capability to wipe out entire cities and landscapes. One notable event is the Tunguska event, which occurred in 1908 in Siberia, Russia. During the Tunguska event, an asteroid or comet fragment exploded in the atmosphere, leveling trees over an area of more than 800 square miles. The blast was so powerful that it registered on seismographs as far away as the UK. Fortunately, the area was sparsely populated, so there were no reported human casualties. However, if a similar event were to occur over a populated area, the consequences would be catastrophic. Past impacts, such as the Barringer crater in Arizona, USA, which was formed by an asteroid impact about 50,000 years ago, serve as a stark reminder of the potential devastation. The Barringer crater is nearly 1 mile wide and 570 feet deep, showcasing the destructive power of asteroids. Asteroid impacts can lead to widespread destruction of infrastructure, loss of life, and long-lasting environmental effects. Understanding and monitoring asteroids are crucial to mitigating the risks posed by these celestial bodies. Climate change. Asteroid impacts can trigger dramatic climate changes, with one of the most notable effects being global cooling caused by the injection of dust and debris into the atmosphere. This phenomenon, known as impact winter, can have far-reaching consequences. Understanding the effects of impact winters is crucial for preparing for and mitigating the risks posed by asteroid impacts. While the chances of a major impact are rare, the potential consequences are significant enough to warrant continued research and monitoring of near-Earth objects. Human survival. The survival chances for humans in the event of an asteroid impact would vary depending on several factors, including the size and location of the impact. However, early warning systems and preparedness measures would be critical in saving lives. In densely populated areas close to the impact site, the effects would be catastrophic. For example, the impact that created the Chicxulub crater in Mexico, believed to be linked to the extinction of the dinosaurs, released energy equivalent to billions of atomic bombs. The shockwaves, heat, and resulting wildfires would pose immediate dangers to human life. Even regions far from the impact site would not be safe. The Tunguska event in 1908, where an asteroid exploded over Siberia, leveled trees over an area of more than 800 square miles. If a similar event were to occur over a densely populated area, the consequences would be devastating. Asteroid impacts can also trigger secondary effects that can affect the entire planet. For example, the impact could create tsunamis if it strikes an ocean, leading to coastal flooding and widespread damage. The impact could also send debris and dust into the atmosphere, blocking out sunlight and leading to a nuclear winter scenario. To survive an asteroid impact, communities would need to prepare similar to how they prepare for other natural disasters. Early warning systems, such as those used for hurricanes and tsunamis, would be crucial in alerting people to evacuate or take shelter. Underground shelters, like those built in some tornado-prone areas, could provide protection from the initial effects of the impact, such as shock waves and heat. Stockpiling food, water, and other essential supplies would also be important to ensure survival in the aftermath of the impact. While the chances of a major asteroid impact are rare, they are not impossible. By learning from past disasters and taking proactive measures, humanity can increase its chances of surviving a potential asteroid impact. Economic impact. The economic repercussions of a large asteroid impact would be immense, with far-reaching effects on infrastructure and global supply chains. The destruction caused by the impact itself would result in the loss of critical infrastructure such as buildings, roads, and utilities. Rebuilding these structures would require significant time and resources, leading to a slowdown in economic activity. Additionally, the disruption to global supply chains would have widespread effects on industries around the world. The destruction of key transportation routes, such as ports and railways, would hinder the movement of goods and services, leading to shortages and price increases. Furthermore, the economic impact would extend beyond the immediate area of impact. The global nature of modern economies means that disruptions in one part of the world can have ripple effects across the globe. Overall, the economic impact of a large asteroid impact would be severe, with long-lasting effects on the global economy. Understanding these potential impacts is crucial for policymakers and disaster planners to prepare for and mitigate the risks posed by asteroid impacts. Scientific response. In order to track asteroids and calculate their potential impact trajectories, scientists use a variety of tools and techniques. One of the primary methods is ground-based telescopes, which are used to observe and track asteroids as they move through the sky. Additionally, space-based telescopes, such as the Hubble Space Telescope, can provide valuable data on asteroids, including their size, shape, and composition. To calculate the potential impact trajectory of an asteroid, scientists use mathematical models and computer simulations. These models take into account factors such as the asteroid's speed, trajectory, and gravitational interactions with other objects in space. Once an asteroid is identified as a potential threat, scientists can propose various methods to deflect or destroy it. One possible method is to use a spacecraft to intercept the asteroid and alter its trajectory. This could be done by either impacting the asteroid with the spacecraft or by using the spacecraft's gravitational pull to gradually alter the asteroid's path. Another method is to use a nuclear weapon to destroy or deflect the asteroid. This would involve detonating a nuclear device near the asteroid, which would create a shock wave that could alter its trajectory. While these methods are theoretically possible, there are still many technical and logistical challenges that would need to be overcome. Additionally, there are ethical considerations to take into account, as the use of nuclear weapons in space could have unintended consequences. Overall, the scientific response to potential asteroid impacts involves a combination of observation, calculation, and intervention. By continually monitoring the skies and developing new technologies, scientists hope to better understand and mitigate the risks posed by asteroids. Prevention and mitigation. International efforts are underway to prevent asteroid impacts, with organizations like NASA's Planetary Defense Coordination Office (PDCO) leading the way. The PDCO is responsible for tracking near-Earth objects, NEOs, and coordinating efforts to mitigate the risk of potential impacts. One hypothetical strategy for deflecting asteroids is to use nuclear weapons. By detonating a nuclear device near an asteroid, the blast could alter its trajectory, steering it away from Earth. However, this method comes with significant risks and uncertainties, including the possibility of fragmenting the asteroid and creating multiple impact threats. Another proposed strategy is to use gravitational tractors. This involves sending a spacecraft to rendezvous with an asteroid and using its gravity to gradually pull the asteroid off course. While this method is less destructive than nuclear weapons, it would require a long lead time to be effective. Other mitigation strategies include using kinetic impactors, which involve crashing a spacecraft into an asteroid to nudge it off course. and deploying solar sails or mirrors to reflect sunlight onto the asteroid, causing it to slowly change course. Overall, preventing asteroid impacts requires a combination of early detection, careful monitoring, and international cooperation. By working together and developing innovative technologies, we can better protect our planet from the threat of asteroid impacts.